Hi everyone, this is Tanmay Banerjee. Welcome to my channel Text Know How. Herein we are again with a new video in the playlist Programming Concepts in Depth. Today we are going to discuss about algorithms, source code, compiler and decompiler. So let's start. Algorithms. So whenever you are given a task, before executing that task, you have some plans and strategies in your mind, right? In order to start with that task and start acting on that task or start performing that task. Now, writing those plans and strategies in simple English language is known as algorithm. Okay, so now it has some much more on it. That is, whenever you are given a task, you first of all think, you should be thinking, or we should be, most of the time we do think, to break that task into subparts and then perform it. So it makes it much more easier to perform as well as much more quicker. So thus, whenever we are given a program to write, we first of all think about it, we plan it, and then we, during the planning and the thinking process, we do break that task, the program which we have to write, into much more simpler steps, and we write those steps in pure English language somewhere, and that is known as the algorithm for that program that will help us write the program. Now then we start writing our program based on that algorithm. Now we select a specific language, we follow the grammar and the syntax for that language, and then we write that program. Once we have written, we are ready to execute that program, right? Now to execute that program, that specific language will have its personal software that will understand whatever you have written and will convey the same to the processor or the hardware, specific hardwares that are to be conveyed. Now that software is known as the compiler. So this compiler is nothing but somewhere in between your program and the processor. So your processor doesn't understand your program, and we won't understand what the processor understands. So we write something which we understand, and then we have someone in between, in intermediate state, that does the transformation work. It converts into some form that the processor understands, which is nothing but the binaries. So we will look into that in much detail. So let's get into the next slide, which helps us to understand that. So first of all, you have written your source code, then comes the preprocessor. The source code is read by the preprocessor. Now preprocessor does what? You might have included some files in it, in your program, which will help your program to run or execute. Okay, that file may contain some part of pre-written programs which you don't want to write. You want to just use those instructions in your program. So what you do, you link that file, right? You add that file. Now this preprocessor does nothing but access those files, actually includes those files, and creates a whole summary of the program, which is, we can term as pure source code. Now your source code is entirely ready with whatever is required, right? Now this compiler is ready to understand that. Now once the compiler gets the source code, it starts transforming into what we call it as assembly code. Assembly code is also understandable by human, but only to specific peoples who have read through some assembly programming languages. That is difficult to understand first of all, and that is difficult to remember. So that's why we have came up with some higher level languages which the humans can easily understand and remember, such as C and C++ and all sorts of Java and all. So now compiler understands that pure source code after the processed all the files and all. A compiler does what? It converts, but before conversion it does something much more. What it does? It checks your entire code, whether you have followed the syntax and used proper keywords from the grammar of that particular language. If it finds something wrong, it prompts. So it helps in that aspect also. And then the actual work is to convert it into assembly code, and then that assembly code is provided to the assembler. Right now the assembler understands its assembly code and converts it into machine code. Now there is written relocatable machine code. Okay, relocatable means this machine code can be understood by any of the machines of same type. Okay, so if you access this code and provide it into some other machine, it will understand. So that's why relocatable. Okay, so now that machine code is given to the loader or linker. There is some other program that is known as loader or linker, which does what? First of all, it converts that machine code into absolute machine code, that is binaries, and then it links to your converters, that is analog to digital and digital to analog. For in case of compilation, it will be digital to analog. Okay, now those analog signals are provided to the specific hardware. Okay, so that's how the compilation process works. And just the vice versa of it, if we just run from bottom to top, that is what the decompilation process. So when decompilation process comes into picture, when you provide some input, right? So you press some keys in your keyboard, so you provide an impulse, and that impulse is then again converted into some form of machine code that again the compiler understands. Before that the assembler understands, and then the assembly code, and then the compiler understands. So this is how the compilation and decompilation process goes. This is an important aspect to understand before you start programming, and that's why I went through this, so that you have this concept in your mind and then you start writing a program. This helps a lot while writing a program, believe me. So this is enough for this video. We will be back with a new concept in the next video. So till then, if you like the video, press the like button and please do subscribe. Stay safe, stay happy. Thank you. Have a great day.